Hey everyone, it is Mr. Vargas here, looking to help out Math 3, this time with homework 6.2, and today our focus is solving logarithmic equations and inequalities. Before we go forward, let's take a step back and let's just quickly remember the two different forms. First, we've got the exponential form, and that looks something like this. You've got your base b raised to the y power equal to your x, and then if we want to rewrite this equation in logarithmic form, it means the same exact thing, but we just write it like this: log base b of x equals y. Remember, our essential question is, what is the exponent that satisfies this logarithm? What is the exponent? You want to figure out your y. Okay, without further ado, let's jump into some examples from your homework. Number 1 says you've got log base 2 of 32 is equal to 3x, and we need to solve this for x. So let's go ahead and rewrite this thing in exponential form, meaning I have 2 to the 3x is equal to 32. Okay. From here, let's try to rewrite this 32 with a base of 2, and we can do that really quickly. 32 is the same as 2 to the 5th power, I believe, and now you've got 2 to the 3x on the left hand side. Remember, when our base is the same, and we can then set our exponents equal to one another. Pretty cool. So let's go ahead and do that. So you got 3x is equal to 5, divide by 3, you get x equals 5 over 3. And it's fine to leave it just like that. Moving on to number 2. We've got the equation log base 3 of 2c is equal to negative 2. And this one we are asked to find the value of c. So let's go ahead and rewrite this in exponential form. We've got 3 to the negative 2 power is equal to 2c. Let's simplify this left-hand side. 3 to the negative 2 power is the same thing as 1 over 3 squared. That negative just means I flip it on down. Negative exponent, flip it down, okay. And let me write everything else out. Equals 2c. Okay. I've got 1 over 9. 3 squared is 9. To make 2c. Okay. Divide by 2 on this side, and divide by 2 on this side, which is the same thing as multiplying by 1/2. So 1 over 9 times 1/2 is equal to 1 over 18, which is equal to c. So c equals 1 over 18. Excellent. Let's keep rolling. Number 3, we've got the equation log base 2x of 16 is equal to negative 2. Setting this one up, we're going to get 2x as my base to the negative 2 power, which is equal to 16. Once again, this negative exponent means we need to flip it on down to the bottom. So we've got 1 over 2x, and actually let me put this in parentheses, 2x squared. That negative exponent becomes a positive. Alright, simplifying this, we've got 1 over 4x squared, which is equal to 16. Let's see, I could just go ahead and multiply this side, the left side by 4, getting that to cancel, multiply this side by 4. So now you've got 1 over x squared is equal to 64. Let's just go ahead and flip both sides. So let's make this become x squared, and let's make this become 1 over 64. So now you've got x squared is equal to 1 over 64. and then finding x, square root both sides, and that leaves you x by itself. The square root of 1 on top is just 1, and the square root of 64 on bottom is 8. So x equals 1/8. Okay, let's jump down to number 7. This one is a little bit tricky because we haven't learned about this just yet, but we will. So we've got log base 4 of x plus log base 4 of 27, and that is equal to 3. Whenever you have the same base right here and here, we've got 4 here, and we've got some addition happening, this is just another way to rewrite the logs as a product. And basically what I mean is you have log base 4 and x becomes times 27. So it would be x times 27. This is called the product rule of logarithms. We can split it up into addition if we were to think about going backwards. So with that said, let's simplify a little bit. You've got log base 4 of 27x, and that's equal to 3. Using exponential form, let's set that up. So you've got 4 cubed equals 27x. Okay, simplify on the left. 4 cubed is just 64. 27x on the right, divide by 27 on both sides, and you end up getting x equals, you can just leave it like that, 64 over 27. That's fine. Alright, number 9 says we have log base 4 of x plus 12, and that's equal to log base 4 of 4x. Okay, rule of logarithms, if our bases are the same on both sides, that means this value here has to be equal to this value there. If we're going to, put an equal sign in between and balance that equation. So we can actually just pull out the x plus 12, set it equal to 4x, and solve. Pretty easy. Okay, subtract an x on both sides. Get 12 equals 3x. Divide by 3 on both sides, x equals 4. Alright, let's go down, let's actually jump to the second page, starting with problem 11. Now we're solving inequalities involving logarithms, but before we do that, let's talk about an important rule. Property of inequality for logarithmic functions. Basically, if there's two things you need to remember. If b is greater than 0, so your base is, b is greater than 1, if your base is bigger than 1, your x is greater than 0, and you are given something that looks like this, log base b of x is bigger than y, then you are going to use the fact that x has to be bigger than b to the y power. Alright, so that's your first little note. Second note, and this time it says if your base is bigger than 1 and your x is bigger than 0, but this time you're working with a less than, log base b of x is less than y, then you have to use the fact that your logarithm has to be bigger than 0, or your x has to be bigger than 0, but less than or equal to b to the y power. Okay, so this is important and this is important. So let's look at a few examples. Let's try out number 11. We've got log base 2 of 2x is greater than 2. And this particular inequality follows rule number 1, because we've got a base bigger than 1, our x is bigger than 0, right? Our x is going to be bigger than 0, and our log base b of x is bigger than y. So we're going to use this idea right here, x is greater than by. So let's get this inequality set up in this form here. So I'm going to take 2x and write that greater than my base, which is 2, to the y power, which is also 2. Okay, solving from there, we've got 2x is greater than just 4, and then we can divide both sides by 2, and you would get x is greater than 2. That's all we would need for that one. Alright, let's jump to number 13 really quick. So we've got this inequality now. We've got log base 3 of x plus 3, which is less than 3. And for this one, we notice that our base is bigger than 1, but this time we're working with a less than. So we actually need to set this one up as rule number 2. So it needs to be in this form right here. So let's do that. Let's put a 0 as our bound, our minimum bound, and then we'll put x plus 3 in the middle, and that is less than our base raised to that exponent, 3 cubed. Okay, solving that out, you've got 0 is less than x plus 3, which is less than 27. 3 cubed is 27. We can then subtract 3 from here, but if we do that, then we've got to do it to the left and the right. Subtract 3, so you end up getting negative 3 is less than or equal to x, because that canceled out, and then you've got 27 minus 3 is 24. So that would be your solution set right there, with negative 3 being your lower bound and 24 being your upper bound. Okay. Alright, last one, number 19. Looks really tricky, but it's not too bad. We've got log base 10 of 3x plus 7, and that is less than log base 10 of 7x minus 3. Okay, on this one, we've got log base 10 on the left and log base 10 on the right, so we can just cancel out that log and just work with what's in our x position. So bringing down 3x plus 7 is less than 7x minus 3. Pretty cool. These canceled out. And then from there you can solve it. Let's subtract 3x from this side, subtract 3x from this side, add 3 to this side, add 3 to this side, and you end up with 10 is less than 4x. Divide by 4 on both sides. Get x is less than or equal to 10 divided by 4 is the same as 5 over 2. Whoops. 5 over 2. And then you could rewrite that as x is bigger than or equal, or just bigger than 5 over 2. Alright, and that's it. Good luck on the rest of the homework assignment, and see you in class.